This is a second part of a previous video. Now here let develop the superposition equation of equilibrium of forces, which is AD is equal to ADL plus S into D. Now we know the value of AD1, AD2, ADL1, ADL2. Taken this EI outside, we have stiffness matrix, and the also we know the coefficient of stiffness matrix. The unknowns are d1 and d2, that means theta b and theta c. Putting the all values, we have this equations, and now the take this 2, which is ADL1, plus 2 toward the left hand side, it become minus 2. Now the first row of a stiffness matrix is 3.33 into theta b plus 0.67 theta c, taking EI outside. Now take this minus 18 toward the left hand side, it become plus 18, and the second row is second row into this column, 0.67 theta b plus 3.33 into theta c, in bracket, and taking this EI outside. So we have these two simultaneous equation. By simplifying, we have d1 is equal to theta b is equal to minus 1.75 EI, and d2 is equal to theta c is equal to plus 5.76 EI. Now let's find out the end moment by using a slope deflection equation. Consider the first column AB. Now the formula, we know that MAB is equal to MFAB plus 4 EI by L theta A plus 2 EI by L theta B plus minus 6 EI by L square into delta. Now delta is 0 here, non-sway frame. Now theta A will be 0 because the fixed end. So we know the fixed end moment MFAB is 16 plus 2E, moment of inertia is 2I, and length is 4 meter, into theta B is minus 1.75 divided by EI, so it becomes 14.25 kilonewton meter. For end B, MBA is equal to MFBA plus 2 EI by L theta A plus 4 EI by L theta B plus minus 6 EI by L square into delta. Now again the non-sway frame, so delta will be 0, theta A will be 0 because A is a fixed support. So by putting the value, we have MBA is equal to minus 16 plus 4 EI by 2I divided by 4 into minus 1.75 divided by EI, it becomes minus 19.5 kilonewton meter. So these are the end moment for the column AB. Now consider the beam BC, and the end moment for B is MBC is equal to MFBC plus 4 EI by L theta B plus 2 EI by L theta C plus 4 plus minus 6 EI by L square into delta. Now the delta will be 0 because non-sway frame, so this term will be 0. Now theta B theta C will be there because B and C there is a rotation. So by putting the value of theta B and theta C as calculated earlier, so it become MBC is equal to MFBC is 18 plus 4 EI by 3 into minus 1.75 EI plus 2 EI by 3 minus 5.76 divided by EI. It become plus 0 is equal to 19.50 kilonewton meter. Now calculate end moment for end C. So MCB is equal to MFCB plus 2 EI by L theta B plus 4 EI by L theta C plus minus 6 EI L square delta. Now this delta will be 0, non-sway frame. Now putting the value of theta B, theta C, and MFCB, which is minus 18, and theta B is 5.76 divided by EI, and theta C is minus 1.75 divided by EI. Now length of a beam is 3 meter, and the moment of inertia is I. So putting the all value, we have MCB is equal to minus 11.49 kilonewton meter. Now let calculate for the column CD. For column CD, for end C, MCD is equal to MFCD plus 4 EI by L theta C plus 2 EI by L theta D plus minus 6 EI by L square into delta. Again the delta term will be 0 and here is a fixed support, so theta D will be a 0. So only theta C term will be appeared, and now the fixed end moment is 0, no load condition. By putting the value of theta C 5.76 divided by EI and moment of inertia 2I, length is 4, we have this value MCD, which is 11.52 kilonewton meter, close to 11.49 kilonewton meter. Now next is for end MDC, MFDC plus 4 EI by L theta D plus 2 EI by L theta C plus minus 6 EI by L square into delta. Again the delta is 0 and the theta D is again the fixed end, so 0. And by putting the value now MFDC, again no load condition, so that value also 0. So only theta C value will be there, and that value, by putting that value and moment of inertia 2I, length is 4, we have the MDC is equal to 5.76 kilonewton meter. So we have all end moments. Now draw the bending moment diagrams. Now bending moment diagrams, for the point load we know that 32 kilonewton free bending moment diagram, it will be a triangular fashion, WL by 4, it becomes 32, W is 32 and L is 4. So by putting the value WL by 4 in the equation, we have 32, it become WL by 4, we have 32, and here also the for point load it is in triangular fashion, it become again WL by 4, W is 48 and length is 3 divided by 4, it becomes 36 kilonewton meter. Now the for end moment at A, the end moment is 14.25 and it is positive, so we have to rotate in anti-clockwise direction about A, it coming toward the left hand side, so show toward the left. And at end B, the end moment is minus 19, so we have to rotate in a clockwise sense about B, it coming toward the left hand side, so show toward the left both value you see here, and by joining these value we have end moment diagram. Now next is for BC. For B end, the value is plus 19.5, so rotate about that B in a anti-clockwise direction. After one rotation, arrow coming up, so show up. Now at end C, it is minus 11.49, so rotate about C in a clockwise direction, an arrow coming up, so you have to show up, and then by joining you will get end moment diagram. Now for the column CD, for C the value is plus 11.52, so rotate in a anti-clockwise direction about C, arrow coming toward the right, so show toward the right. And at D the value is again plus 5.76, so positive side you have to rotate in a anti-clockwise direction about D, arrow coming toward the left hand side, so you have to show toward the left. By joining you will get the triangular way. So this is about the end moment diagrams. There is no any load on the column CD, so free bending moment diagram will not be there. So this is about the bending moment diagram for the given problem. Thank you.